All right, back to work. Sorry, I ran into the lunch bell and interruption, so I had to stop for a minute. Now I'm coming back and doing it. I changed locations, and this location sounds like it has a little bit of an echo in here, so I apologize for the sound. I did just see Emily and McKenna walk by during the middle of the sixth period wandering around. I waved to them, but neither one waved back, so they kind of dissed me a little bit, but I'll let it slide. They can make it up to me Tuesday. If you go to Fresno Bagel, just plain bagel, nothing on it will do. Thanks. All right, so we talked about creating a residual plot. So when we're doing a residual plot, the calculator actually will do the residuals for you. So when we did the stat calc number 8 linreg, okay, let me zoom back in on the calculator. It displayed the A, which was the intercept, the B, which was the slope, R squared, which just says the constant of variation, and the R, which is our correlation coefficient. Like I said, it's RR. So, pirate talk. Back when my daughter was little, it was Captain Feathersword, I think, for the Wiggles. Now maybe Jack Sparrow, but R is the correlation coefficient. Now, what the calculator also did, which you can't see right now, is it already created a residual for every one of your x's. And the way you find the residual is you're going to press second and list. And when you press second and list, it will show all of your lists, and it has a contribution and then a resid. Okay, the resid is actually your residuals. Okay, and what we're going to do is we are going to store those residuals in L3. So I'm going to exit back out of here. So what I'm going to do, oops, no, I don't want to exit out of there. I'm going to go to residuals. Some of your calculators may be number 7, some it might be number 8. For the 89s, I don't know where the heck it is. You're going to have to find it yourself. But I'm going to press enter. And then way down here, there's a store button, STO. It's right above the on. Okay. If I press store, and I want to put it in L3, so I press second, L3. This put all of my residuals in L3. And if you don't believe me, we're going to look at stat, edit. Notice your L3 column now has some data in it. So L1 was your X's, L2 were your Y's, L3 are all of your residuals for each one of those values. Okay, so residuals are in. So to do a residual plot, we have to change, because now instead of plotting X and Y, we're going to plot X and Y hat. So remember, L3 now contains our Y hats. So what we have to do is we go back to stat plot. Like I said, I'm going fast right now, but you can pause, rewind, show it again. That's the benefit of a video. So I'm going to go back into stat plot. I'm still a scatter plot, but I'm going to change this from L1. I'm going to change this to L3. Okay. Now when I graph, I've got my line of best fit. You got to get rid of that. Oops. So I'm going to delete my line of best fit. There we go. Something you may commit, a problem you may have. So I've just shown you an example. Okay, so now I graph, zoom, number 9. Now I have a residual plot. Now notice we have some values above the line. I have some values below the line. So the values above the line mean that my residual or my predicted Y value is greater than my actual Y value. The points below the line mean that my predicted or expected Y hat, that value is less than my actual Y. And then this one little point right here, it looks like it's almost on the line, that Y hat and Y value are almost the same. So there's no difference. So when we go back to our notes here, if we sketch the residual line plot, have 1 point, looks like it's up here somewhere. We have a point, about on the line. We've got another one down here. We have two more here and here. There, there. And then 1, 2, 3. And then we had a couple more over here. We still should have the same number of points as we had, same number of dots on our scatter plot as we have in our residual plot. So before we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on this residual plot. So if we go back on the scatter plot, or maybe not even the scatter plot, but on our list, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we had 12 points here also. So residual plot, scatter plot, two different plots, but they're both necessary when we're doing these problems. Okay, you're going to hit some problems that says, please complete a complete correlation regression analysis for the following data. Well, these are two steps in that process, is to create a scatter plot, tell me what it looks like, give me the model for the line of best fit, tell me the residual plot, and what does the residual plot tell me? Now, for the residual plot, let me go back down to the residual plot. We are looking for a couple of specific things. Okay. Now, what we're looking for in the residual plot is no pattern. Okay, so conclusion. Okay, so what we're looking for in a residual plot, we're looking for no pattern in the data. Okay, and no pattern means that the linear model is appropriate. So no pattern means the linear model is appropriate. So for this one, there's no pattern. So conclusion, okay, the linear model, no pattern in the residual plot. So linear model is appropriate. Okay, now what I mean by a pattern, you may have one, let's see how fast I can do this here. You may eventually run across a residual plot that looks like this. It might have a point, 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 a point. Okay, it has a very distinct pattern to the residual plot. If we do see something that looks like this means that the linear model is not appropriate. It's probably a different model, maybe an exponential model or power model would be better. We're going to explore exponential and power models in Unit 10, which is in March, but we need to know what we're looking at in a residual plot. Now, steps to get to the residual plot. Again, remember, we have to store the residuals in L3, and we have to change our stat plot to L1 and L3. What's going to happen is many times you're going to plug data into your calculator into L1, L2. You're going to try to graph it, and you're going to get a DIM, a dimension error, when you graph. And the reason is you forgot to switch your stat plot back to L1, L2 when you're doing a regular scatter plot. So you have to be very careful. There's a lot of little calculator things you have to do to make sure it's always working. But if you have a DIM error, that's what you need to check. Another error that might occur quite often is because you might see residuals in L3, but they might be the residuals to a previous problem because you forgot to do the linreg and calculate new residuals. So a lot of little steps that you have to be really careful about that you'll get a lot of practice doing, but you need to make sure you are on top of the calculator. Okay, we get to use the calculator, but you still have to learn how to use it correctly. Now that covers the first page, front and back of the notes. Now the next two go by a lot faster. Okay, this first one, more 2.3, it's for slope and residual analysis. So we have numerous points we use to calculate line of best fit, otherwise known as least squares regression line. The equation of the line was y hat equals, that's supposed to be y hat, and I'll draw a little hat on there so that we know that is y hat. Y hat equals 64 plus 2.58x, and that 2 is extra, so we'll get rid of that. Okay, now we have to interpret the slope of the line. This is a common question. This is a common question that most of you will get wrong, and it's not because you're not sure how to analyze the slope. It's because you're going to leave out one very important word. So I'm going to highlight it and bold it and underline it and maybe even italicize it. So hopefully you can emphasize what it needs to be. But when we're interpreting the slope of the line, we're explaining how y is going to change as x changes. So the general term is for every increase or decrease in the x, okay, y is, now here's the okay, so here's the general form. When they ask you to do a slope analysis, this is what it needs to look like. Okay, and I'm going to, let's see here, predicted or estimated. Those words we'll bold them, we'll underline it, we'll italicize it, we'll highlight it. Those words have to be in there. Okay, so let's see, what would this be a good one for? Let's say, let's see. Okay, let's just say this is an example of the height of a tree in centimeters. Okay, let's say x is how old it is and y is the number of centimeters. So if we were to use that example, age of tree, and let this be height in centimeters. So if I were to analyze the slope in this case, we would say that, okay, for every additional year, so for every additional year, that's the increase in the x is the age. So for every additional year, okay, it is predicted or estimated, either one of those words will work, that the height of the tree will increase by the slope. So the height of the tree will increase by, now the slope, that's the 2.58. So if you were asked the question on how to analyze the slope, so interpret the slope of the line, for this example would be for every additional year, it is predicted or estimated that the height of the tree will increase by 2.58 centimeters. Okay, so how are we going to calculate a residual by hand? Because you do have that question every once in a while. By hand, what is the residual? So if one of the points in the data was 15 and 100, so we're saying at 15 years old, this tree is 100 centimeters tall. What is its residual value? Now the residual, we said it's the actual minus the predicted. So it's y minus y hat is the residual. And right now we know the y. Okay, we know the y is 100, but we don't know the y hat. Well, in order to get the y hat, we have to put x into our model, into our regression equation. So y hat would be 64 plus 2.58 times 15. We're plugging x in, not the 100. I almost put the 100 in. I was going to have to edit it out, but I caught myself. But 64 plus 2.58 times 15 is 102.7. So when I calculate my residual, it would be 100 minus 102.7. So my residual value for this 1 point is negative 2.7. So if we were to look at that on a scatter plot, do you think 15,100 fell above or below the line of best fit? Okay. Well, remember we said since it's negative, any negative residual values fall below. So let's say if we had this, and here's my line of best fit. Okay. The point might be right here. But if we were to estimate, let me see what kind of other little tools I have up here. If I were to estimate this, let's say this is where x is 15, this is 100. Okay, my estimate, I would do it by going up to the line and coming across. So here is my x, y hat value. This is my x, y value. All these lines over here is where my hand's touching the screen. They're not part of the notes. So this value we said was 15 and 100. This value was 15 and 102.7. Now, if we were to plot that 1 point on the residual plot, okay, x was 15, it was negative 2.7, so it'd be about right there. Okay, so not too bad. But residuals defined by hand, it's y minus y hat. To find the y hat, you plug x into your equation, into your linear regression equation. This is y hat, and then it's y minus y hat. So 100 minus 102.7. Negative values fall below the line of best fit. Positive values fall above the line of best fit. And if this turns out to be 0, it is right on the line of best fit. Okay, so that is the more of 2.3 notes. Now 2.4, okay, 2.4, it's more of a review. Okay, but it goes through a lot of different parts that you have to do when you are doing a complete correlation and regression analysis of data. Now there is a lab that we're going to do later this week that has all of your steps prompted for you. Then there's also a lab or project where it just gives you a set of data and says, okay, go create a complete correlation and regression analysis of the following data. And the page is almost completely blank except for the data. Well, by the time you're done, that whole page should be filled with a scatter plot, a residual plot, equation, analysis of the slope, analysis of the R, analysis of the R squared. We're going to explain that a little bit right here. Okay, all those things need to be part of your analysis. So it says analyze, do a complete correlation regression analysis. The calculator does a lot of work for us, but we have to be able to put the what's on the calculator into words and explain it clearly so that this would make sense to somebody who's not taking statistics, or to Alex Roach. Okay, so what we want now is you are going to put these values into your calculator. Now, I said statistics is kind of morbid. This is an example I was talking about the other day. So we're looking at the number of boats registered in the thousands and the number of manatees killed each year. Okay, and this is, I think, the example of something in Florida. So if you put all the values into your calculator, and I will give you a minute or two to do that, and I will do it right along with you because I want to show you what you want to do as you're setting it up. Very first thing, we want to clear these values out. So L3, we press clear, enter. Don't press delete or it'll disappear. Go up to L2 and I press clear and they go away. And I go to L1 and I press delete. Notice my L1 disappeared. Now it's L2. I'm just getting rid of this other stuff. Okay, now notice when I go across, I have L2, L3, L4, L5, L6, but I don't have L1 anymore. I deleted L1. If you happen to do this, go up to L2, press second in the insert. Okay, now ask you to name this list. If you name it L1 again, notice all your data is still there. So we didn't clear the data, we deleted the whole column. So I want to clear and not delete. Okay, so now let's put in those values. So we had 447, 460, 481, and I won't talk because I'll mess up if I'm doing it, obviously. And now my Y's, which are the number of manatees killed.
Hi, Jason.
Hello. Looks like I missed one up here. Okay, so now I have all my data in. So first step was scatter plot. So if I press graph, invalid dimension it says. So remember what I said. You have to go back in. Let's do quick. You have to go back in and you have to create, or you have to fix your scatter plot so it's back to L1, L2. Oops. Okay, now we graph and we zoom 9. Okay, we have a scatter plot. Okay, so that's step 1. So if we go back to the note paper, go ahead and put your scatter plot on there. So I have a point, and how many points should I have here? 1, 2, 3. Okay, so I make the scatter plot. Next step says determine the regression equation. So the regression equation, Remember, back to the calculator. Stat out number 8, and we'd have L1, L2. So remember, the important values are the A and the B. So the regression equation is, let's see here, so y hat equals negative 41.43 plus 0.125x. Okay, determine and explain the correlation coefficient R. Now, just by looking at this, without doing the R part, okay, what is the shape? Okay, it's linear. Would we think that would be strong or weak? Okay, it doesn't look too terribly strong, and it's definitely positive. But remember, we want to look at the correlation, the actual mathematical calculation we did to check the correlation. This says it's 0.941. So R is 0.941. Okay, that means there is strong positive correlation. Okay, so when we're dealing with correlation, we want 3 parts. We want the actual value, the strength, and the direction. Okay, so the number always goes between -1, +1. Strong, weak, no correlation, moderate correlation, depending on how close it is to 1 and -1, and then either positive or negative. This one's definitely positive, and we always know based on the sign. This was positive, 0.94. Now, something we haven't looked at yet is the R squared. Now, R squared is called the constant of variation. Okay, what the constant of variation is, it tells me how much of the change in Y can be explained by the change in X. Okay, so for this problem, R squared is 0.886, and R squared is just R squared, 0.941 squared. So what we can say is that 88.6% of manatee deaths can be explained by boat registrations. We'll do boat registered. Okay, so R squared, constant of variation, how much of the change in Y can be explained by the change in X? Okay, so now to graph the regression equation through the scatter plot, back to our calculator. Y equals, and it was negative 41.43 plus 0.125x. And now when I graph, there's my line of best fit. Okay, so everybody hopefully is to that point. Remember, if you're unsure, go ahead and pause, rewind, check it again. If you still don't get it, email me a question. I'll be at a conference on Monday, but if you're still having trouble, email me. and I should be able to have a couple minutes here or there to email back. Now, the next thing down at the bottom has about sketching the residual plot. So let's see if we remember the steps to get that done. I'm recording. Okay, let's check those steps again. So we have to go into list, which is second stat. And I go down to my residuals. And I store, remember, second in the STO button. Or just the STO button, sorry. Store in L3. Okay, now I'm going to check my list, make sure it's in there. All my residuals now are there. Two things I have to do with my calculator now. First one, I have to delete my line of best fit. So that's out. And the second thing is I have to go back into my stat plot and change it from L1, L2 to L1, L3. And graph, zoom 9. Okay, and there's the scatter plot. So notice it looks like there's 1, 2, 3, 4, 5, 6 points above. There's 1, 2, 3, 4, 5, 6, 7 points below, and it looks like there's one about halfway on, halfway off the line of best fit. So our questions now, it says explain how a residual plot reinforces the R statistic. Remember, R represents the correlation between the linear correlation between an X and a Y. So the scatter plot, the way it reinforces it is we are looking for no pattern. If there is no pattern in the residual plot, that means there is a linear correlation. So when there's no pattern in the residual plot, it verifies that a linear model is appropriate. So let's go back here. And oops, so hold on. Right there. So no pattern in a residual plot verifies that a linear model is no pattern in the residual plot means the linear model is appropriate. Now, so there's where you're going to put your residual plot. Now let's go back to this R squared stuff here. So it says R squared is the constant of variation. It tells me how much of the change in Y can be explained by the change in X. Now, notice that's only 88.6%. So that means there's another 13.4% out there that is causing this change in Y. When we get to Unit 10, we'll have multiple X variables in one question, but right now we only have one X, one Y. That other 13.6% or 13.4% is called lurking variables. There's other things out there that are causing manatee deaths besides boat registrations. So lurking variables are any other conditions that can contribute to change in Y. So in this case, maybe other things were global warming, maybe predators. I don't know how to spell predators, so we'll say sharks, maybe disease. There's many different things. This is where you're not always going to have a right or wrong answer. So any other conditions that contribute to the change in Y are called lurking variables. Now, just a couple of things down at the bottom. Almost done. Association does not imply causation. Remember, that's from 2.1 notes. And a restricted range. We talked about restricted range a little bit when we talked about extrapolation. So restricted range, come down here. Okay, restricted range is the regression line. is only good through the range of data which so like we said on the Kalmans, we put the boundaries around where the x's were. So the regression line is only good through the range of data which produced it. So we want, if we make predictions outside the x range or either above it or below it, remember the term, it is called extrapolation. So to use the equation outside, hopefully undo works just like in everything else because I just need to undo something. Let's see, undo. Ooh, getting closer. There we go. Okay. Okay, so to use the equation outside of okay, so using the equation for data outside that range would be extrapolation. So a couple of big words there, restricted range, extrapolation, but it's important vocabulary, so make sure when you're answering questions that deal with these, you use both of those terms. And there are questions like that on the quiz and I believe on the test also. So that was our very, very long note. It was a long video to watch. It's not as exciting as iCarly, I'm sure, but you know, we'll get it down. So questions, please email or rewind and check it again and see if maybe the second time I explained it better. But hope you enjoyed the day, and I will see you on Tuesday.